Hi, everybody, and welcome to podcast. This one's going to be 2.3, woo, where we're going to explain trends in the periodic table. And I'm your host, Mr. Fowler. All right, so first thing you need to know, size and nuclear attraction explains all trends, every one, you better believe it. And this comes from the idea of Coulombs Law. Coulombs Law is that bond energy is Q1, Q2 over radius squared. Really, it's proportional, but really we don't care. What we do care about is Q are the charges, and R is the radius, which is size. That's why it's size and nuclear attraction. So charges are attraction, radius is size. Okay. So for the size of the periodic table, starting on the left-hand side, hydrogen's big, and it goes to helium, which is smaller, right? You have more protons, so the electrons pull it in a little bit. So if this radius is 10, this radius is 8. Notice it's not a very big change, right? If this radius is 20, this radius is 17. It's not exactly linear, so I don't want to give you any kind of craziness. Na is big, argon is small. So if you're looking at your periodic table, I'm comparing these guys right here to these guys right here. Okay? So as you go across, there's more protons. So the electrons are pulled in more because the Q's increase. All right, so, and then as we go down, notice how it gets larger because more energy levels, right? So on the periodic table of the elements, I have it here twice. I don't mean to have it here twice, but that's okay. We'll call this one size. So as I go this way, it gets bigger, and as I go this way, it gets bigger. Francium is my biggest element. Now, electronegativity is a little bit different. The one with the most electronegativity is francium. So let's see if we can explain that. Okay. So electronegativity is X equals E negative, right? So, oops, that's not right. Electronegativity is X plus E negative yields X negative 1. It's the ability to attract a bonded electron. Smaller size is more attractive. So let's talk about that for a second. This is more attractive, increases because smaller, because fewer energy levels, right? Also, smaller leads to more attractive. So if you really like crunchy Cheetos, but the fluffy Cheetos are closer to you, you might eat fluffy Cheetos. Okay. As you go across this way, you have more protons, more attractive protons. So more attractive. So attracts electrons better. Ionization energy, here we go, we got another one. So ionization energy, I'm going to have X turn into X plus 1 and then an electron. It's the energy to remove a valence electron from a gaseous atom. So I'm going to remove it, I got to rip it off. So this means a smaller size is more attractive, so it takes more energy to remove. Smaller. Hey, how's it going?
I know your second block, but it's easier than sending an email. I want to meet with you whenever, so
Sure.
cover stuff I missed.
Sure, absolutely. I'm here. How about tomorrow morning?
Yeah, I can do that.
Okay. So this is smaller, more attractive, so takes more energy. Absolutely. Remove a valence. Do you think he knows? I don't think he knows. So when we go across, you have more attractive protons. So, and smaller. So takes more energy to remove. Okay. You can identify, we cut this today. This is what you get for a late start day. We get to cut something, bum, 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 which is so nice. Look at this. Look at all this cutting. Look at cut. You get to be gone. You get to be gone. You get to be gone. All right. Now we're going to do reactivity. Metals react by losing electrons. So metals are large and unattractive. So the biggest and least attractive metal is the most reactive. That means francium's the most reactive because this is, as you go down, you get larger because more energy levels. So attract, or instead of attract, I should say lose electrons better. Lose electrons better. And as you go to the left, you have fewer protons. So less attractive. So lose electrons better. So nonmetals react by gaining electrons. So it's kind of the opposite. Nonmetals are small and attractive. The smallest, most attractive nonmetal is the most reactive. Bum, 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 bum. Fluorine is the best, right? As you go up, it's smaller, fewer energy levels, therefore more attractive. And as you go to the right, you have more attractive protons. So attract electrons better. Last part, finding replacements. Elements in the same family are the best choice to replace elements. Radium replaced calcium in the radium girls. Ooh, that's a good icky story. We'll have to show you that in class. Arsenic replaced phosphorus in some proteins and changed good proteins. Yay, I'm building muscles to poison. Oh no, my muscles are dying. Okay? And we no longer need to love shielding the way we did before. So that means I got out of here in under 7 minutes. Toodles.